Okay, just want to give you guys some encouragement right here. This is, where it gets kind of really in depth, and want you to stay with it. Don't get discouraged. We'll get through this, and if you missed a few of these as we begin, and don't panic. That's what we're going to practice. We're going to spend a good chunk of time here on equations, so that this is the big thing going forward. There's going to be a few other things at the end, but this is going to be the big thing going forward that you use in all the rest of your math classes as you go on. So we want to make sure that we get a good feel for it. So I'm going to solve these from yesterday and then build a little bit on it. We're going to keep going just a little bit with these what are called one-step equations, and I'll explain that later. But let's solve these first from yesterday's assignment, and I will use red, so don't panic. It's like, oh, we missed them all because he's using red ink. But, make sure, like I said, you draw your fence. Now, all of these, the variables are already on the left side. We're going to do some today with what happens when they're on the right side or in a different spot. But for right now, they're on the left side where we need them to be. We're just needing to move the constant over here. So we want to make this 0. So we're going to subtract 8, which means we need to do that over there. And we're going to be left with x equals 9. Okay. Same process here. I know they're bigger numbers, but we just need to subtract 35, and this is going to be 49. Okay. And you can use calculators for this, if there's certain ones that you want to use. And as they get bigger, you probably want to use a calculator. Now, your calculator, unless you know how to use the scientific part of it, and even that can get just as hard as being able to solve these. They're not going to be able to do the solving for you, but you can at least plug in 84 minus 35 if you want to. I'm okay with that. So as you go on, it just kind of speeds things up where we're focusing on more on how to solve these as opposed to just the general math of it. Okay, Math Lab, we had to do these by hand because we need to learn how to do that. But right now we're trying to just make sure we're going efficient and quickly. So if you need to do that, you can. Okay, now right here, instead of subtracting like we did here, we want this to be 0, so we got to add 22. And so we're going to add 22, and x is going to be 58. Okay. Same thing here, we're going to add 13. We're going to add 13. The difference is, okay, this is a v equals, and in this case, excuse me, we got a -4 plus 13. This is just like integers. It's not anything different. You may need to even write it off to the side so you can see it. -4 plus 13, which is going to be 9. Okay, so now that integers gets into play there. V is 9. And if you, like I said, you need to plug it back in to check. 9 minus 13 is -4. Okay, so that's how you can check it. We're going to add 10. Add 10, so m is 18. And I'm just drawing that fence every time to remind you to keep doing that. Okay, like I said, that's why I don't do it right away at first, because I don't do that when I do these problems, but you want to kind of get into that practice. Subtract 7. This one's going to end up being -3. Okay, 4 minus 7. Okay, so we're getting practice with integers still. I told you when we did integers that was never going to go away now. So that's where that comes out. And once again, you can plug this back in and check it. -3 plus 7 is 4. Okay. And then this one, you're going to take away 9, and y is going to be -11. Okay, -2 minus 9. If you got to write those out side by side to see it, you can do that, but that's -11. Or some of you already figured out in your calculators you can actually put in negative numbers. You're like, why didn't I know that then? Well, we need to learn how to do that part without it. But you can plug in -2 minus 9 and you get -11. Okay? So those are the ones from yesterday. I want to answer those first. Okay, and now let's build a little bit and do a couple different examples and then kind of introduce a new part of this. We always got to keep building and keep going. And that is, okay, well, what happens when maybe x is in a different spot. Okay, so meaning it's not at the beginning anymore. It's still on the left side, but it is not at the beginning of the problem, where all those ones that we just did, it was at the beginning of the problem. So, what happens then? Now, when it's like that, and let's do one, well, I'm going to do a couple like this first, and then we'll do one as a different example here in a second. But here is an example of, okay, it's still on the left side though. So we're still good with that. We don't need to move the variable. It can stay where it's at. It's on the left side of the fence. But now, instead of it being at the beginning, it's over here, and you got this plus sign, and then here you've got a 8, and we've got to remember what makes this a little bit trickier is this is a positive 8. Now before, we already knew that because, with those problems like from yesterday, it looked like this, okay? And you're like, oh yeah, I know that's a positive because it's got a plus sign. Well, remember, now we've got to assume that the plus sign's there, and how we know that is there's not a negative there, okay? So it's a positive 8. We gotta think back to integers and say that's a positive 8. So that means we still are doing the same goal of isolating this variable. We need to get rid of that 8. So, just doesn't matter where it's at, we need it to be 0, so we're still going to subtract 8, which means over here we need to subtract 8. And so we're left with this positive x equals 12. Well, we don't need that positive. Remember, that positive and that 1 that's here, we don't need to even see. So we have solved it, still in one step, but it's just, it looks a little bit different because this is first, but we did the exact same thing. You made this a 0, you did the same thing over here, and then all you need to know is like, okay, what's a positive x? So I don't need to do anything else. It's x equals 12. Okay, that can be another one. I'll just do another quick one. 12 plus y equals -3. Let's throw in an integer there. So once again, got our fence. It's on the left side. Just need to get rid of this 12. So we do that over here. We're left with this plus y, but it's a positive y, which is what we need. These cancel out, and this is going to be -15. So y is -15. Okay? It's still true. Like if I was to plug this in, 12 plus -15 equals -3, we know that becomes 12 minus 15, which is -3. Okay, so it's still a true statement, still the same process, just looks a little bit different. Okay, well what happens if this number out here is negative? Okay, what happens if the number out in front is negative? And you've got, it's still a couple key things, I keep repeating this. Still on the left side of the equal sign. Okay, so that's still true. You still need to isolate it, so you need to move this. The only difference is now it's already negative. Well, that means you still got to get it to 0, which means you're going to add 7. That's going to make it 0, and then you're going to add 7 over here. You still got this positive x, which is just x, and x is 11. Okay, you plug it back in, -7 plus 11, that equals 4. Okay, so that's, here's where they're in front. A couple of them are positive, one is negative, but doing the same thing from yesterday, it just looks a little different because it's in a different spot, but you're doing the exact same work. Okay? All right, so let's look at this though. Those are all plus the variable. Well, what if you have, let's do 6 minus x equals 4. Okay, 6 minus x equals 4. Okay, so almost these same kind of problems except for now we're subtracting the variable. Now a couple key things at the beginning, and I know I'm sounding repetitious, but that's what gets us through this. Keep repeating. As long as you keep those goals in mind, it makes these rules a lot easier. Variable's still on the left side. Still need to isolate it. So you need to get rid of this 6. Okay, it's a positive 6. So we're going to subtract 6. Okay, they cancel out. But now we're left with negative x, okay, not a positive x, okay, not a positive x, but a negative x equals, in this case, negative 2. Now, here's where this is going to be one more step, because we're not solving for negative x, okay? We have to solve for positive x. There is a long thing I could take you through on what to do here. Meaning, you know, we could go through y and go through it all. I feel like right now, a quick way, I made the mistake one time in class going like a magic trick. It was like poof, you know, and well, now I've already done it again and it's on the internet, so it'll never go away. But from that point on, for like 2 terms, all I heard was poof, poof. And so, but it is one thing we can think about is we can, okay, if I'm gonna make this positive, so I've made it from negative to positive, then whatever the sign is over here, remember the balancing. If I change the sign here, then I have to change the sign over here. And so if that's the balance of it. If I take away or make it, you know, change the sign, then I need to change the sign over here. Now there's a longer explanation, but I feel like right now, that's a good kind of practice. Let's say, just as a quick example, I had negative x equals 4, okay? You know, these are both negative and I changed them both positive, but what if this is negative? And so I need to change the sign over here. Well, that means I change the sign over here, okay? What you're technically doing is dividing by negative 1 on both sides, but like I said, this is just a quick, almost like magic trick. If I change the variable, then balance it out and change the sign on the other side. Okay, so let's do another one of those. Let's change it from x. Let's do 12 minus m equals 8. Okay. Actually, let's do 82. That way you don't have to erase anything, but we can try this. Okay, so variable still on the left side. Need to get rid of the positive 12. So we're going to subtract 12. And we got negative m equals 70. Okay, this is why I changed that to 82. I wanted this to be a positive. So now I've got this is negative, this is positive. I need to change this sign. So if I change that sign, I have to change this sign. And m is negative 70. Okay? Let's throw in some integers. Let's do negative 3 minus y equals negative 4. Okay? So a little bit, now you see a lot of negatives up there, but keep going back to variables on the left side. Need to isolate it. Need that to be 0. Okay? That means I'm going to add 3 and add 3. I get negative y equals negative 1. Negative 4 plus 3 is negative 1. And I need to change this sign, so I need to change that sign. So y is 1. If you plug it back in, I promise you, the original problem is still, actually, I don't know if I'm still on screen here, so the original problem was this. Okay? So I plug in 1 to that, negative 3 minus 1 is negative 4. Okay, so that's a true statement. All right, so that's all the different little wrinkles of what happens when they're in different spots or if they've got a negative in front of them. So, you know, that's kind of what you do with that. The last little wrinkle on this kind of problem is what if the variable's on the right side? Now, let me give you an example. So let's do 22 equals x plus 14. Okay, and let's say the problem. Now these are ones that we did the first day of this, but the difference is now the variable's on the right side. Now, really, technically, it doesn't matter the variable on the right side. You could solve it on the right side, but I just really feel like that becomes then a whole nother thing and it gets to be confusing. If we just kind of hold to that thing to get it to the left side and we know that's our goal, you know, it makes it to where you're kind of taking that out of it, okay? And you're just focusing on the thing of having on the left side and isolating it. Now, here's the little concept I want to show you. If I put up here 8 equals 8, does it matter which side of the, I could switch places. You wouldn't even know I switched places. That looks the same. But let's say I took that 8 and put it over here. That doesn't change the problem, right? It's still true. I changed places. You didn't even know I changed places, but it's still a true statement. Well, that's true up here as well. I know these look different, but if I change places and say, okay, this side needs to go over here of the fence, and this side comes over here, we just change places like a mirror. That's what, you know, that is. I know I've called it a fence, but now I call it a mirror. But if I just change places, then it's still a true statement, just like I changed places here. Well, voila, which I'm not sure is French or Italian, but it's like presto, which I've already said poof now, and presto. So I'm really gonna be getting all those on the internet. But change places, it's still a true statement. Now I can solve it just like we've been doing, so that's not real hard. You just change places and then begin your problem. Here's your fence. You need to isolate this, okay? And hey, it ended up with 8, didn't know that. But just that's what to do with the variables on the right side. Let's do another one and let's throw in some negatives here. So let's do 16 equals 12 minus x. Okay, well, let's change places. 12 minus x on this side, let's put negative 16 over there. That's to get the variable on the left side. We can just change places. Now we got our fence. We need to isolate this. This is a positive 12, subtract 12, but we've got a negative x. Over here we got a negative 28. Well, I want to solve for regular x, so I change the sign. So I change the sign over here, and I get 28. X is 28. Now that combines several things, but that's doing it all together, okay? So let me check my time here. And let's stop with that, because I'm going to put several problems up here and give you a chance to practice this good and well. So let's do so I'm throwing in integers, I'm throwing in negatives, throwing in these positives. Okay, oops. If I count, this is 5. Let's change letters a little bit, give some variety. Okay, let's put some on the right side. Actually, sorry, that should be, you need to keep these lowercase. Okay. Let me put 1, challenging. Well, of course, you know, if you're going, whoa, that's challenging enough. Let's do one a little bit. Okay. Of course, that one's just a little bit bigger numbers. So. All right. So let's do those and get practice with that, and then we'll keep building. But that way, you get some practice with this, and kind of go through and see what you're doing. And if you have questions, you know, you can write me on there on Google, and we'll go from there.